Alright, so in this video we're going over quadratic equations, and in this case we're going to be talking about horizontal shifts. Horizontal shifts. And just like with vertical shifts where we went up and down, with horizontal shifts we're going to be going left and right. And so again, what we can do is we can graph y equals x squared, and then we can graph two other graphs with maybe a plus and a minus associated with it, and see how that affects our horizontal shift. Now, if you remember with vertical shifts, we had x squared plus 2 and x squared minus 2. In this case, what we're going to do is we're going to have y equals x plus 2 all squared. And we're also going to have y equals x minus 2 all squared. Okay, so slightly different from our vertical shifts. The addition and subtraction is going to happen within brackets of the x, and it is also going to be squared with the x term. Okay, so we'll see how this affects our graph and how it horizontally shifts it. So again, we'll take a few points here, make a table, and see what we get. So we'll have a y and then x, and again, let's just go from positive to positive 2 all the way to negative 2. So 2, 1, 0, negative 1, and negative 2. So with positive 2, we're going to get 2 plus 2, which is 4, and we're going to get 4 squared. 4 squared is 16. With 1, we're going to get 1 plus 2, which is 3. Okay, 3 squared is 9. With 0, we're going to get 2. 2 squared is 4. With negative 1, we're going to get negative 1 plus 2. Okay, so negative 1 plus 2 is going to be positive 1. Positive 1 squared is just 1. Okay, so a little bit different with our symmetry here. And with negative 2, we're going to get negative 2 plus 2, which is 0. Well, 0 squared, that's just going to be 0. Okay? And we'll do the same thing here with this bottom one. So we're going to have a y and an x. And again, we can graph it from 2 to negative 2. So we're going to have 2, 1, 0, negative 1, and negative 2. And again, if you substitute in 2 minus 2 is 0, 0 squared is 0. You might start to notice a pattern here. 1 minus 2 is going to be negative 1. Negative 1 squared is just 1. With 0, we're going to get negative 2 squared, which is 4. Negative 1, we're going to have negative 1 minus 2, which is negative 3. Negative 3 squared is 9. And with negative 2, as you can guess, we're going to get 16, because we get negative 2 minus 2, which is negative 4. Negative 4 squared is 16. So you can see the y values here are basically flipped. And now I want to talk about just one, we'll add one more point here. In this top graph, we'll add the point of negative 3, and we ask ourselves what happens then. Well, with negative 3, we have negative 3 plus 2, which is going to be negative 1. Negative 1 squared is just 1. So we can see that there is some sort of symmetry, and if we had negative 4 and negative 5 and negative 6, we would start to see these numbers 1, 4, 9, 16, they would reappear. So there is some sort of symmetry here, okay? And same thing with this one. If we were to add at the top here, instead of 2, if we added positive 3, which I don't have space up here, so I'll add it down here, of positive 3, we would basically get 3 minus 2, which is 1. 1 squared is just 1. So we would see the 1 and the 1 again, and again, that would be up here. I just don't have space. So there is symmetry still. It's just the numbers that we chose for our x values, they, in this case, they just happen not to include that. Okay? And so now if we were to take y equals x plus 2 squared and y equals x minus 2 squared and y equals x squared and graph it, here's what we would get. Okay? we would get these three different graphs. And again, let's label all of them. So the red one we know, we've worked with this before, we're comfortable with this. The red one is just y equals x squared. We'll take a look at the blue one next. So with the blue one, again, really what would be happening here is you would be graphing, these graphs, and you would be putting the points down and then connecting them. So you would know which one you're graphing. But in this case, they're already graphed. So let's just see what points relate to the blue graph. So we have a -2, 0 here. We have -3, 1. We have -1, 1. So let's look for -2, 0. So if I look at -2 here for this one, we have 16, so that doesn't work. With this top one though, we have -2, 0, so that works, and we have -1, 1, that also works, -1, 1. So in this case, the blue graph is going to be y equals x plus 2 all squared, and therefore the green one is going to be y equals x minus 2 squared. And again, if we want to double check, we have the point 2, 0, 2, 0 associated there, as well as we have the point 1, 1, that's also there. We have the point 3, 1, which is, remember, down here. So yes, the green graph is indeed correct, and we're going to get y equals x minus 2 all squared. Now the first thing that you might notice about these graphs is that the y equals x plus 2 squared is actually moving us to the left by 2 units. And the graph of y equals x minus 2 is moving us to the right. Shouldn't it be the other way around? And that makes sense. It's what most people would assume. The -2 should move us to the left and the +2 should move us to the right. It mathematically makes sense if we look at our number line. But the reason that it's not that way, the simple reason to think about it is to just say, well, we're just going to think about it as opposites. So +2 means move to the left and -2 means move to the right. That's one way to think about it, and that's fine to remember it that way. But the way that I like to think about it is, if I want to be at the origin, if I want to be at 0, 0, then in order to get there from x plus 2 all squared, I need to subtract 2, right? Because if I take -2 and I substitute into x, I'm going to have -2 plus 2, which is going to be 0. And 0 squared, well, that's just 0. And so I get back to the origin. So really, I'm not looking at this +2 or this -2, but instead I'm looking at, what do I need to do to my x value in order to neutralize this +2 or this -2, or to counteract it? Or how do I get back to the origin, with this +2? Well, I need to subtract 2 from x, or I need to add 2 to x. And so that way, now I see the -2 and I'm moving to the left, or I see the +2, I need to add 2, because 2 minus 2 is 0, and that's what I'm actually doing. I'm moving to the right, I'm +2, I'm adding 2 to my x value, and that's what's happening here. So again, that's kind of how I like to remember it. It's a little bit easier for me. But with that being said, let's talk about the properties of these graphs. We'll only talk about the blue and the green one because we've done y equals x squared a few times now, and I don't want to bore you with that. So let's talk about the blue graph, y equals x plus 2 squared. So again, we can talk about the axis of symmetry. And in this case, the axis of symmetry, if you remember from our 2 previous videos, was always on the y-axis. But this axis of symmetry is not. It's moved. It's shifted horizontally, if you will. In this case, it's shifted to the left horizontally by 2 units. So we can see that our axis of symmetry is at x equals -2 in this case. Okay, and similarly, our vertex, which is associated to the axis of symmetry, is right here. Okay, and our vertex has the coordinates, a y coordinate of 0 and an x coordinate of -2. Okay, we also see that it opens up. I'm not going to mention that because You should be pretty familiar with opening up and down by now, but it does open up. The other things we'll talk about is going to be the X and Y intercepts. So in this case, the X-intercept is going to be right here, so it's where it crosses the X-axis. So this is the X-intercept, and it happens at X equals -2. And there's only one X-intercept in this case. And then we'll talk about the Y-intercept. Now the Y-intercept is where it crosses the Y-axis. And if we take a look at our Y-axis here, where does it cross? Well, it crosses it right over here at this point. So this is our Y-intercept. And it happens at Y equals 4. Okay. Now it's very nice that we can see it here on the graph, but what if we wanted to actually find that out using math? How could we do that? Well, we could just go to our equation, y equals x plus 2 squared, and we could say, okay, where is x equal to 0? Because where x is equal to 0, that's where the y-axis is. Okay, so we're going to set x equal to 0, and we're going to see what we get. We're going to get 0 plus 2. 0 plus 2 is 2, and 2 squared is 4. So we're going to get y equals 4. Okay, that's our y-intercept. Pretty simple. And similarly, to get the x-intercept, what we would do is we would say, okay, well, where's the x-intercept? Well, the x-intercept is where y is equal to 0. So we would take our equation, y equals x plus 2 squared, and substitute in 0 for y. We would have 0 equals x plus 2 squared. And then we would need to expand and simplify, but what we would basically get is we would get that x is equal to -2. And if we want to do that real quick, we can. We can go 0 is equal to x plus 2 squared. 0 is equal to, remember, x plus 2 squared is just x plus 2 times x plus 2. Now, we might not be familiar with how to expand this quite yet, but that's going to be coming up in a video very shortly. But in order to expand this, we would basically get y equals x squared plus 4x plus 4. Or this might not really be meaningful. We could also take a look at this simplified expanded form, and we would basically come to the conclusion that x is equal to -2. But again, that's going to be coming up in a video shortly where we talk about our quadratic formula, which will help us solve some of these questions. But yeah, that's how you get the x-intercept. And that's all of the features that we can talk about in terms of the blue graph. If we move to the green graph, we'll see similar things. We have this this axis of symmetry, and in this case, the axis of symmetry has moved to the right by 2 units. Okay, so this is our axis of symmetry, and it just so happens to be at x equals 2. Okay, and the vertex is here as well, so we can label that, and the vertex is at 0 comma positive 2 as opposed to 0 comma negative 2. And then we can talk about the x and y intercepts, and again, the x-intercept, there's only one, and it's located right here. So this is our x-intercept, and it's located at x equals positive 2 instead of -2. And our y-intercept is also located here. Okay, this is our y-intercept, and that happens at also y equals 4. And again, the way you would get these is similar to how we got it for the blue graph. Getting the x-intercept is a little bit more difficult, and again, as I said, we'll talk about that in a few videos. But getting the y-intercept you should be able to do. You would just get y equals, you would get y equals 0 minus 2 squared. Y equals 0 minus 2 is -2 squared, and -2 times -2 is 4. Y equals 4. That's where your y-intercept is. Okay? So this is everything you need to know about horizontal shifts. And now the last thing that we're going to talk about in the next video is going to be stretches and compressions. Okay, and that will basically just take our graph of y equals x squared and either make it look more narrow, kind of like this, okay, like that, or more wide, kind of like this. Okay, so that's basically what the stretch and compression is going to be. It'll either compress the graph inwards or stretch it outwards. And that's going to be coming up in the next video. And then after that one, we are going to combine all of these shifts that we've made, so the horizontal and the vertical shifts, as well as the stretches and compressions. We're going to combine it all together, and we're going to see how these equations can change these graphs. We're going to analyze some of them, and we're also going to be getting a little bit more into the math of things, specifically how to get the X-intercepts, and we'll also be talking about the Y-intercepts. Okay, so that's all coming up in the next video.